This is the Infrastructure Matters podcast, brought to you by the Futurum Group. We explore the latest developments in hybrid cloud computing and the technology that underpins it. In each episode, we'll dive deep into the latest trends and technologies that are shaping the hybrid cloud computing landscape. The Infrastructure Matters podcast is for information and entertainment purposes only. Please do not take anything reflected in this show as investment advice. Now, your co-hosts, Stephen Dickens, Camberley Bates, and Krista Maycumber of the Futurum Group.
Welcome, everyone, to 2024 and Infrastructure Matters. This is our first podcast of the year, and I am thrilled to have Randy Kerns joining us from Bonaire and his dive trip. I think everybody knows that he's retired now, quote unquote retired, which that will never happen, but here he is. And we've asked Randy to spend some time with us and reflect on the last 50 years of his career and the industry. So, Randy, welcome.
Thank you. This is actually kind of fun.
And I think we have you in between dives, right? You're
correct. I've been down already, got up about 45 minutes ago, and I'm going again in about an hour and a half.
Do you see anything really cool today?
I saw a bunch of Spanish lobsters, which was unusual. And I saw a number of these worms. They look like millipedes, but they're underwater. And I saw them down around 45 feet. So it's interesting.
Cool. So, I've known Randy for,
Too long.
I know we go back to 2022, or I'm sorry, 2002. There we go. I got it spit out now. You've been in this industry, as I said, for now 50 years.
A little more than that, actually.
Is it really? Okay. Well, we won't go. And what we wanted to do today was just talk about what the 50 years in data looks like, how you've continued to stay so relevant, and probably one of the biggest questions is, why in the heck did you stay in data storage for 50-something years? Because, at one point in time, I said it was the most boring thing in the world.
Yeah, we just didn't take much to prove you wrong. No. Seriously, though, it's been one of these areas that's continually changing. Lots of new things happening all the time, and it's always something to learn. We were talking about when I got into this, the first real way I got into storage was actually in 1971 or 72, in that I was working in a data center in St. Louis, and they were going to be developing a new application. They wanted to know how to optimize the performance when they accessed this information from their disk drives. And these were Calcom disks in those days. And so I started looking into them, and I started learning about count key data and gap 1, gap 2, gap 3, and the time you had to transition the gaps before you could turn the read heads on, and trying to figure out how to optimize accesses for this information from the disk drives we had. Yeah.
So time out. What the heck is a gap?
In a count key data architecture, they actually have different types of what are called gaps, where there's no data recorded, and you have time to control the electronics, and before you turn the read or write heads on again, before you go over an area where you can read or write. And that gap is a transition, and a new when you do a servo mechanism to move to the next one, you wait till you get oriented on a type of gap to know where this starts. Remember, these disks in the disk storage world are concentric rings, and so you have to deal with angular velocity and all these things. And so you get where you're oriented, and then you have a certain amount of time before you can turn the write heads on, and then you can get the count field, and then you can have a key field, which is an index, if you will, and then data, and you have a certain amount of time for each. And if you don't do things correctly, you have to go complete revolution to the same point again to read the data. So it's very critical.
Whole lot different than using solid state and flash, isn't it?
Well, if you remember, I went into Future Systems in IBM, and we were working on the was going to replace the System 370. And we saw all these problems, and we said, okay, well, let's change to a fixed block architecture. So we could just deal with an extent that says, here's a start, and there's so many blocks there, and they're all fixed size. And so it simplified everything and certainly made performance more predictable. But eventually, we didn't do that for the next generation 370. We'd actually done that on we created a fixed block architecture 3380, and then we had to go back. I was involved in that group. We went back and put key data onto that 3380, and the stuff we'd been doing for that new system actually became the System 38 IO system.
Which is still one of my favorite systems.
Yeah, it's the AS400. It evolved it, and it's still fundamentally the same. The only difference is we'd had a unique 48-bit key, and it got expanded to 56 before it finally was released to the field. It's a very unique architecture we worked on back in the early 70s.
So that's the 70s, 80s. I mean, you also went off to start working on this incredible system that was working on his incredible system. Wow, those trade winds are wonderful. You're just like nice and cool. So you also worked on this one incredible system that was way before its time called Iceberg at StorageTek, and you were the lead executive on that. If I
Well, actually, I can't take credit for that. I did get responsibility for it at one point in my career, but I had actually been brought in from, that was my second stint at StorageTek, and Jesse and Dave Weiss hired me to come back. It wasn't Jesse this time, it was Dave Weiss. Convinced me to come back and go to work there. They bought another company, and we were doing another key data architecture storage system. But the concept with that one was to be able to move into open system storage, so move away from key data to fixed block. Iceberg was being developed was several years ahead, and it was very embedded that it was only going to be key data architecture, but it was incredibly novel, way advanced, and the guys that did it were incredibly bright people, and so they'd come up with this, but it was going to be limited. And so we did this deal with IBM at the time to resell both the Iceberg product and the Kodiak product. And Iceberg did well with customers. And at one point in time, they had us change the back end to a serial architecture from the parallel architecture it had. And so I got put in responsible for the whole program for doing that. So that was my part of it. And as soon as that was finished, that's when it was time to say, okay, no new programs, time to move on to something else.
So you then went on to Open Systems, and some great stuff over there. And so tell me how Open Systems was so different, maybe different from the AS400, what you were doing there, what you were doing with the mainframe systems, et cetera. What was what was outgoing there? What was the big shift?
Well, the big shift is those were open from the standpoint that lots of people could contribute, lots of proprietary software was added, proprietary drivers. There was a degree of openness when you could have, one guy somewhat controlling the OS, and then a lot of people wanting changes and trying out changes. And so it was a continually evolving area. From a storage standpoint, there's only so much you can do physically with the storage once you move to a fixed block architecture, but there was a lot of interesting things you can do around caching, around buffering data, creating some type of environment where you can ensure consistency with a network type access. That's where SANS came in '99, and that allowed us to get more utilization out of the storage more than anything else, and do a high degree of parallelism that we didn't have before. So all those things kind of came about nearly the same time. Open Systems kept expanding. To the point today, we've got lots of open source in all kinds of different areas, and that's certainly been beneficial, but it's also been somewhat problematic in that it means all that code has its potential issues exposed to the world to be exploited by people for nefarious reasons. So it makes it a lot more complicated.
Does that mean that it's more exposed than what is being done on the mainframe nowadays?
Oh, absolutely. Absolutely. Yeah, people can go in and find weaknesses, the log4j thing, for example. Uh, and so there's more opportunity. Now, normally in the storage world, the things that happen in the storage system aren't really ever penetrated, if you will. It's more from the application layer above, and things are done to it like encrypt data, delete data, uh, and that's where you end up doing a lot of your protection mechanism in the access to the storage. Certainly, you see it a great deal in the data protection software. Things trying to make sure that since it controls and knows where all the protected copies are, it protecting those copies is utmost important. So in case there's been something else happen, you can get your data back. But you see the applications and the other things being focused on from a protection standpoint, not the devices itself, other than the fact that we're exploiting things to be able to do what's called an air gap. And what that means is that you can write some data and then you don't provide a programmatic way to go after that an application can get to.
So mainframe, future system AS400, open systems, cloud, we're putting stuff in the public cloud now. Have the decision criteria changed at all from the very beginning?
Well, if we narrow it to storage and more importantly, information storage and protection, the problems are actually still the same. They go back to the 60s, 70s, etc. And I want to access it quickly. I want integrity. I want to be able to protect it. I want to ensure that I don't have inadvertent access, all these other things. And then I want to do it for the least possible cost while still meeting these other criteria. Those were all present, when I first started. Those haven't changed. The mechanisms have changed. Certainly some of the requirements have gotten more intense, if you will, and more varied. But the fundamental need for what we would call the customer, the IT organizations, they're still the same.
Why do you say that the more intense? Why is it more intense? What's cause? Is that, yeah, I'll leave it there.
There's two things. One, there's always a screaming about wanting more performance. That just wants to ramp up. And
but I thought solid state was supposed to just kind of make all that happen.
Oh, it made a world of difference. But what it did is it moved where the bottleneck was or where the limitations were from the device access to the network, and then from the network to the data mover functions done in the servers. So all the solid state was fabulous in that it made the performance tuning much simpler. It limited the amount of effort required to get data quickly, but it exposed the other bottlenecks, which have been addressed. We've seen that with NVMe as a protocol now to get rid of the command response interlock we had before. We've seen it in the server systems now doing these offload controllers, if you will, these DPUs, data processing units, and other things to try and get the processing function away from just handling the movement of data, because that was a bottleneck. So we continue to see these things changed, and so solid state did make a world of difference from the performance standpoint. There's never enough there. But to answer your question, the networking of everything, if you will, blame it on the internet. That's an easy
Well, blame it on Cisco or something like that.
Right? Those poor guys. The networking of everything has created opportunity for these attacks. And now these attacks are saying, okay, how do we prevent this? And really your last line of defense is to restore data that you've made a protected copy of. And so that's brought the focus into the storage area, the management of that, the security of that. And that's where that intensity has come in, because that really is the last line of defense. You can put all the other avoidance and detection things in, but there are people trying to always figure out ways around them, and it's tough to keep ahead of them sometimes. And but you ultimately resolve to getting that protected copy, whether it's S3 object lock on object storage, or whether it's even the tape that's been removed. I gave you the story one time that when I was in a startup company, we brought in a guy to run the IT operations that I got to know real well. He'd been in, flying SBDs for the Navy right after World War II. He was a really funny guy, but he was one of these guys that at night, every once in a while, I'd see him taking several tapes out, and these are the big round tapes, to his car. And I said, "What are you doing?" He says, "Oh, I keep a copy of backup tapes at home. I haven't opened." He says, "I got a refrigerator in the basement that's not plugged in. Says, we ever need to get data back, I got it."
Okay, so you have to tell that one story though about the repairing of the tape down in
That
Colorado
was
Springs.
that was a disc.
Oh,
That
that
was
was a disc. Okay, got to tell the story for folks. This is
well
this is
that
a fabulous, fun story.
okay. Well, I was working for IBM, and one of the guys that was working in the Denver field office was a fraternity brother of mine, so I knew him real well. He knew I'd been working on the 3350 attachment to 3850. We were making a switch over. It was called Madrid staging was the project. And so I obviously learned a great deal about 3350s and the embedded code for them and all that. And so they were having a problem in the, let's just say Cheyenne Mountain. And
And
they
Cheyenne Mountain is exactly what is Cheyenne Mountain?
just everybody knows. And anyway, he was saying they couldn't figure out what it was. And these were the symptoms. And I said, "Oh, I know what that is because I'd seen it before." And he says, I told him, he says, "Okay, well, I'll tell the FEs." And apparently, they wouldn't let the FEs in to repair it, but they disconnected it and rolled it out. They put the fix in and rolled it back in. just
So we
absurd.
do have to explain Cheyenne Mountain because there's going to be some Europeans that are watching this. So
It was a secure facility. Let's just put it that way.
and literally in a mountain, literally in a mountain. So yeah, down in
Yes, that
Colorado.
was kind of interesting, and it just so happened we were talking about this because he knew I'd worked on these things.
That is great. That is a great story. So, and we kind of touched on this, but maybe a little bit more succinct in it. What do you see in your 50 years there? What were the biggest shifts?
Well, you brought up solid state. That's been one of the biggest ones, and people, I just keep telling this to people, you can't underestimate the value of moving away from electromechanical devices. Um, when I started, we had key punches and card readers, and one of the things you had to do when you first start is you have to learn to fix your own key punch because you're going to be working at 3 a.m. and the repairman ain't going to come. So you learned how to fix all these, and these are all electromechanical devices. If you get away from the electromechanical, you can be so much more productive. And so that's what's been happening with solid state. That's really a really big deal. The other ones are maybe outside of the storage area, but they have to do with development. Development's really changed. When I first started, you had maybe 64K of memory, K. And so you wrote a lot of elaborate software to be able to page in pieces of code to execute. And then you had to do self-modifying code in some cases. Now we don't even think about the size of memory we have, unless you're the database guy. And now all of a sudden we've got CXL coming along that's going to give us massive, massive amounts of memory effectively. So the idea of managing and doing IOs, the things I was talking about earlier about count key data, index sequential operations, and all that all goes away. So now you treat all of the fact that you have data, it's all amorphous, and then the system handles that, putting it into memory and handling the IO to simplify everything. So the big changes are this change to infinite memory, if you will, with CXL that's coming, the change getting rid of electromechanical devices, that's a big deal, and then the development tools dramatically different. When I first started, you had this triumvirate. You wanted the big thing in my career was to be able to say you designed your own processor, wrote your own assembly language for it, and then you wrote your own high-level compiler for it. So I had done that. And nowadays, if you talk to anybody about doing that, they look at you funny. Just those things aren't necessary anymore. There's so many great tools that are available, and the programming languages are so much more powerful. Sometimes they're a little too wordy, verbose, and some people misuse them. And anytime somebody says YAML to me, that's an example of somebody misusing them. But 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 the point is, things have gotten much simpler. And one of the things we're starting to see now is this transition away from having to write your own scripts, write your own APIs, etc., to these low code or no code tool sets. And that's going to, again, expand the horizon to where you have less, specializations, more, you're going to get more out of the people. It's going to be very interesting.
Wow. Okay. So let me shift in the last section here. Given all the current industry shifts, you've been working with the data architects or the storage architects. Now we're kind of talking information architects kind of folks, changing their titles a bit. Your advice to the current people responsible for information and data infrastructure, how do they stay relevant? Because a lot of people say, oh, you don't need to manage this stuff anymore, et cetera. What's your advice to those people?
Well, there's a lot of people say that, but what you're more valuable if you really truly have an in-depth understanding. You're much more valuable. You can explain when there's questions asked. And more importantly, you can figure things out when something goes wrong. And invariably things go wrong. So if you're at that superficial level, then your value is not there compared to somebody that has that more in-depth knowledge. Now, the way you get your in-depth knowledge, is difficult. We do a class. I think that helps a lot of the current IT people to broaden their horizons, understands how things work and what's different and why there's different value from different solutions, etc. But working in it is one of the better ways. One of the things I always advocate is for somebody to really understand something, they need to understand to a level where they can explain it. And so if they can take any particular area and go into it, do the homework, go to a class, read about it, and then be able to maybe teach a one-day class on it to somebody, that's a demonstration that they really understand it. In our industry, we call people that understand something subject matter experts, and that'll get watered down eventually. But right now, it's normally a badge saying this person has done their homework, they've lived it, and they really understand it. So for right now, it's a good area. It used to be that there were other, people had specializations or knowledge, and we gave them different titles and things, but those tend to get diffused over time.
Yeah, and I will segue and do a bit of a big commercial on the class that we're doing, which is April 16th and 17th. We're going to be sending out information on it next week's for registration. It's the last one we're going to do. It's
In the U.S.
In the U.S. Well, you're right. We'll be over in Europe for our buddies over there. You get 2 days of this. 2 days of this type of knowledge going and being delivered in that class. And some of the cool stuff we're going to be talking about this year is all about what we're calling the AI data platform, which is like, if you're involved or you want to get involved with generative AI, guys, this is kind of this is the next generation of where this data is going and what's happening. And by the end of this next year, we're going to see, this kind of like a rocket with most IT organizations. So, anything you want to say about that class?
Yeah, we're going to talk a lot about that, but it's not that you want to get involved. I think a lot of the IT guys are going to have it thrust upon them.
Dump.
And so they really do need to understand the framework, what's going on, what their role is going to be, what the issues are, and where there's real value, because it can be quite overwhelming initially. And a lot of the people that they may be working with don't come from an IT background, so there's some terminology, and I can't help in teaching patience, but it's something you do need.
And oh, by the way, Randy is coming back from Bonaire for this. He's not staying there for the entire.
No, just this week. You run out of money after a while here.
So we will be in Boulder, Colorado for that in April. So we would love to have you guys all here and just kind of like take over the hotel that we're doing at the Boulderado. So we will welcome you. Randy, thank you so very much. We're going to do a couple more of these, I think, over the next month. And kind of see if we can pry a few more things out of his brain. And next one that we'll be doing is going to be covering some of the mainframe stuff, which is send that over to all of our mainframe buddies that we love
Okay.
and are dear. Okay, thank you very much, guys. And don't forget to click and follow. We're going to put a link in here so you guys can come over into our class. We're going to love to have you guys. And Randy, thank you so very much. Go dive.
Alrighty.
Go have fun.
All right. Bye, guys.
Bye.